kind of bear with me and pay attention. Okay, the first thing we're doing, remember, is we want to identify whether a system is consistent or inconsistent. To classify it, we solve both equations for y, and then we compare the slopes and y-intercepts. The first one is a dependent system. In a dependent system, how many solutions are you going to have? There we go, good. Infinitely many. In an independent system, you're going to have one solution. In a inconsistent system, we're going to have no solution. Very good. To remember, what makes a system dependent is it has the same slope and the same y-intercept. In other words, these two guys are the same line. And the way that happens, the way it happens that you end up with the same line is you have something like this. And guys, I'm just making equations up right now. You don't necessarily have to copy this down, but just get the idea. If I said x plus y equals 5, and then I took that and made my second line by saying something like 2x plus 2y equals 10. This would be an example of a dependent system. The reason it would be dependent is because, look, if I solve this equation for y, I got y equals negative x plus 5 for that equation. Okay, that's what that is when I solve it for y. So if I took this equation right here and solved it for y, y equals negative 2x plus 10, I would then divide by 2, and I would get y equals negative x plus 5. So again, notice in this problem, I have a slope of negative 1 in both equations. I have a y-intercept of 5 in both equations. So this ends up being a dependent system. If I ask you how many solutions that had, you would say it has infinitely many solutions. Guys, that's how the questions are going to be asked. You're going to come in, you're going to sit down, there's going to be a problem in front of you, and it's going to say, describe this system. So the way you describe the system is you compare the slopes and y-intercepts. To compare the slopes and y-intercepts, you solve both equations for y. Okay? So now I'm going to skip over from a dependent system to all of a sudden over here with the inconsistent system. Remember, what makes a system inconsistent is that the lines are parallel. The reason the lines are parallel is because they have the same slope, but this time, instead of having the same y-intercept, they have different y-intercepts. Okay? When they have different y-intercepts, the equation goes from being on top of each other to now all of a sudden, let's say, again, I'm just making something up here. I'm going to use the same example, but this time instead of making that a 5, I'm going to make it something like 15. So now when I solve this second equation for y, watch what happens. 2y equals negative 2x plus 15. Divide by 2, divide by 2, divide by 2. Y equals negative 1/2, or excuse me, negative 1x plus 7/2. There's still the same slope. Where's the slope at? Use a math term for me. Use a math term for the number in front of a variable.
Coefficient.
Coefficient. So the slope is the coefficient of x. And then the b, the y-intercept, is the number sitting out there that doesn't change. What do you call a number that doesn't change? Very good. So b is your constant. So this time, in this example, I have parallel lines that have same slope, different y-intercepts. And the same slope and different y-intercepts, we say that system is inconsistent. Guys, I'm just going to ask you that. I'm going to say, classify this system. I'm going to say, tell me the number of solutions to this system. And then based on which one it is, that you'll get it. Independent, going to jump off the page at you because it's going to have different slopes. And you're going to get one solution, and that one solution is the point where those two lines intersect. And so it's going to be one solution, but it's going to be in a form of an X and a Y. Right? So what that looks like is these problems here. The directions say solve it by elimination. But just to go over one more of these, I'm going to take number 1 here, and if you need me to, I'm going to take number 2 and solve it by by substitution. But real quick, I ought to be able to look at these problems right here and notice right off the bat that these are all systems that have different slopes. Since they have different slopes, I know the system is independent.